Okay, now I've got it set to the higher voltage. We're going to use 60 volts as our input, and we have basically 100 milliamps going through now with just the bulb on the secondary. And this is what our scope looks like, and our time division is 5 volt and at 40 milliseconds 5 volt divisions. And that's one X1 probe, and there's our volts RMS across the bulb only, and about 1.5 volts range, and that's the light intensity. And again, there is our input. I've got a little heater operating in here, kicked in, so now I've dropped the voltage there. So now what I'll do is I'll flick it to the bulb and diode, and this is what's very noticeable now, the difference in using the high voltage. And wait a minute, what I'll do first is I'll just put it in open coil. So there is our open coil. I'm going to shut off that heater just so we get our voltage back here, so we're comparing the same thing. 60 volt. 0.075 amps is going to the circuit, to the primary coil, and now I will flick it in the diode and bulb and look at the intensity and brightness, and obviously has zero change on our input to the primary because it's operating off of flyback. So there you go. And if you listen to the magnetic field with the coil open and the coil activated with the diode, it's as strong. And I've showed that in previous tests. And now I'll flip it just to the bulb only, no diode. That's the bulb only. And now you can hear that the magnetic field in the coil is like really cut in half. But yet our input to our primary has gone up, and it's reflected there. So that is what I'm trying to get at, is here we can actually have, in the diode with bulb, we've got our full magnetic field for the motor action, and that's what I want to emphasize on. This is not a stationary thing, this is going to be in a motor, so movement is going to be happening, and not robbing the magnetic field from the primary to light that secondary load. And there's our data on the secondary load. Pretty well close to 2 volts, 1.97 volts RMS, and that is basically the data, what it looks like, basically all flyback. So there you go. There is the data once more. That is the bulb on, bulb off, zero change. Bulb on, zero change. And bulb only, dim, only getting 1.5 volts RMS. The scope's having a little hard time reading stable data, but you can obviously see the intensity is way down. So I'm quite sure 1.5 volt is more accurate. It's just that when these get small, these peaks here, it's just having a harder time reading that. And there is the data, and there you go. So the difference between the two different scenarios is basically at 60 volts, 100 milliamps, that's 0.1, is 6 watts. And in the other configuration, when the bulb is producing more light, 0.75, whoops, sorry, I must have taken out my period, 0.075 is 4.5 watts. So here we've dropped basically 1.5 watt compared to that, and we're lighting the bulb with much more intensity with a 1.5 watt drop. So, but you know, we got to look at the whole energy in. I'm not saying that this is over unity. I'm just saying that we can get power out while we're having movement or the motor is operating with this configuration. Don't know if that's what Brad is doing, but that's what I'm going to be doing, and continuing to research that. So thanks for watching. Bye now.